Figures 16.1 and 2, exception handling example that throws exceptions on attempts to divide by 0. In this example, we're going to finally introduce to you the C++ exception handling mechanism. And the basic idea is to write programs that are as robust as they possibly can be, and hopefully that won't fail at execution time. Now, when you're using class libraries, many of those class libraries, as you call their the functions within the classes, will cause exceptions to occur when problems happen at runtime. So an exception is not something that happens all the time. It's an exceptional condition, something that happens once in a while, which, if you're aware that it's possible this could happen, you have an opportunity to write more robust code that can deal with that problem if it ever does occur. Now, in this example, we'll show you not only how to do exception handling, but also if you're writing code that needs to notify somebody else of a potential problem, how to quote-unquote throw an exception as well. Now, before we get into the code in detail, let's run this program and show you how it works. So basically, we have a program that's going to calculate the first number you enter divided by the second number you enter. So for example, if I type 107, I can see that the quotient is 14.2857. Now, if I type 100 and 0, you can hit enter or just space in between. You see that an exception occurred and that I attempted to divide by 0, but my program is still functioning and now just waiting for me to enter the next set of input. Now, normally when you attempt to divide by 0, a problem occurs at execution time that causes the program to terminate prematurely, at least with integer arithmetic. And with floating point arithmetic and the IEEE floating point standards, it's actually allowed to divide by 0, in which case you get actually positive or negative infinity as the result. But in integer arithmetic, you're not normally allowed to divide by 0, and doing so causes a problem that in most systems is going to make your program terminate prematurely. So here, because we were able to catch our attempt to divide by 0, we were able to display an error message to the user indicating that a problem occurred, but now we're being prompted to read in the next set of data. So let's say I type 213, and when I finish that up, I get a proper result. And if I type Control-Z to terminate my input here, you can see that my program terminates successfully. So basically, let's go ahead and take a look first at our main program here to see what's going on. We've declared 3 pieces of data, 2 integers, number 1 and number 2, and a double called result. And we prompt the user to enter 2 integers or end of file to end the input. Now, I don't believe I've shown you this before. We have multiple inputs occurring here in the condition of the while statement. Now, what happens with a cin inside of a while condition is that first it reads a value into number 1, then it reads a value into number 2, and if either one of these fails, the result of this expression is actually going to be a false value, indicating that the loop should not continue. So only if we successfully read in 2 integers will this loop keep executing, and in that case we will then flow into lines 36 through 40, which are known as a try block. Now, a try block is a block of code that starts with the keyword try, and inside the curly braces of that block you place any code that might cause an exception at runtime and any code that you would not want to execute if that exception occurs. So if you look at what we're doing here, we're assigning to result the result of calling our quotient function with number 1 and number 2. If this function returns a proper result, only then do I want to display what the quotient was. If, on the other hand, line 38 fails because of an attempt to divide by 0, I don't want to display a result because I won't have one. So I've put this output statement inside the try block as well to ensure that it will only be displayed if line 38 works correctly and produces a valid quotient. Now, if I successfully work my way through all of the code in the try block, then the catch handler at lines 43 through 47 will be skipped. The only thing that can come between the closing curly brace of a try and the beginning catch is white space and comments, or our white space and comments. So in this case, we have the try block followed by a catch handler. Now, catch handler's syntax starts with the keyword catch, then is followed by a set of parentheses in which we have a data type name and a parameter name. And in this case, divide by zero exception is the parameter name, and it is of type reference to divide by zero exception, which is a class that we're going to take a look at in a moment that we defined. It's here in the header file, divide by zero exception.h. Now, within the catch handler is where you do your error processing. When the try block fails at line 38 because of an attempt to divide by zero, the try block will terminate immediately, thus skipping line 39. At which point it will jump to the first catch handler, and you can have many of these catch handling blocks that start with the catch keyword and then are followed by a block of code. In this case, we have only one. Now, when we jump to the first catch handler, the system is automatically going to test the type of exception that came out of line 38 and see if it matches up with the type of the parameter at line 43. If it does, the exception object that gets thrown will be referred to by this divide by zero exception parameter. And you'll notice that we're using a reference here, which is basically an efficiency issue. If you were to not have the ampersand, you would be making a copy of that exception object and thus have more overhead in your program. And there's no need to copy exception objects. So we refer to the divide by zero exception that gets thrown, and as you can see here, we print out exception occurred, and we take advantage of an inherited member function that we're going to get in our class called divide by zero exception. It's the what member function, which simply returns what the error message was that's embedded in the exception object. And as you saw when we ran this program, and let me just do it again here, if I type 100 and 0 as my two arguments, I have an attempt to divide by 0, and this is what's being produced by the catch handler down here at lines 43 through 47. Now, once you reach the closing curly brace of the catch handler, the exception is considered to have been handled, and now the program can simply continue with the next statement after the try-catch sequence. So if you stop there and look back at the output, you can see it's prompting me for the next set of inputs. That gets me back up to the top of the loop, and now this cin expression is waiting for me to enter two more numbers. So if I stop there and type, 21 and 7, I can see that the quotient out of that is 3. And in this case, I typed in two valid numbers for the purpose of the division, and it allowed me to calculate the quotient. So what happened there is we successfully tried everything in this try block, and therefore the catch was skipped, and we simply moved on to the next statement after the try-catch sequence. So as you can see in this example, we've written some additional code that allows us to deal with this potential runtime problem when it occurs, display a simple message to the user. In a real program, we might display something a little bit more friendly than what I chose to here. Of course, we're just doing this for demo purposes. And separately, we've now made our program more robust, whereas had we tried to do integer division by 0 without testing for this potential problem, our program may have failed. Now, let's take a look at our quotient function. And you can see here that the quotient function is defined above main, and it receives two integers, the numerator and the denominator. And we, in this program, are explicitly testing to see if the denominator is equal to 0. And if it is, rather than attempting to do the division, we are going to throw a divide by 0 exception, and that's the class that we're about to go look at the definition of in a moment. Now, the primary thing that's important when you're throwing exceptions is to have a data type that's associated with the type of problem that occurred. So when you have large libraries and there's lots of different potential types of problems, there could be many different exception data types, exception class types that you can throw, and the primary thing that's of interest to you in an exception type is A, the type name itself, and B, the error message. The type names are what enable you to catch the problems in the catch handlers that follow a given try block. So if you want to be able to do more precise error processing at runtime, it's good to have different types of exceptions for different categories of problems that can occur at execution time. So here is the syntax for throwing a divide by zero exception, or any type of exception. It's the throw keyword followed by a class name and a set of parentheses. And what this is doing is it's an explicit call to the constructor for class divide by zero exception, specifically the default constructor that takes no arguments. And that creates a divide by zero exception object and initializes it. Then that object is thrown into the exception handling mechanism. Now, when a throw statement executes, the function in which it's executed terminates immediately. So we would not even try to calculate the numerator divided by the denominator as we're doing at line 20. Instead, it just terminates the function quotient immediately, and the object that was thrown is sent back to the calling point in the program, line 38. If line 38 fails because an exception was thrown, then the try block terminates, and we jump immediately to the following catch handler. And in this case, we have a matching catch type for the type that was thrown, divide by zero exception. In later examples, we'll talk about what happens if we don't have a matching catch type, in which case we have what we call an uncaught exception, and we need to talk about what's going to happen with uncaught exceptions as well. Now, let's just go ahead and take a look at the definition of the divide by zero exception class. And here is a separate header file where we've defined that. And our class inherits publicly from a standard library class called runtime_error, which is just a generic exception class that represents the concept that something went wrong at execution time. And built into that class is a data member of type string where you can store an error message, and also a member function called what that allows the catch handler to access the exception object and get the error message out of it. In our case, the error message is, of course, attempted to divide by zero. And all we typically put in an exception class is a constructor or a set of overloaded constructors that allow us to initialize the error message string of the runtime error base class. And you could put other data and functions here because it is indeed a class that you're defining. However, we typically try to keep such classes as small as possible for overhead reasons, and also because, again, the primary thing we need is the type name so that we can catch the problem in the first place. And once we've caught the problem, we would then write any code that we need to either deal with the problem at execution time, or at least to shut down our program in a nice manner rather than simply failing and maybe displaying a dialog box on the screen that the user has no idea what it means, or possibly just failing with no message whatsoever in some cases, depending on your platform. So again, the divide by zero exception class inherits from runtime error in this case, so we can take advantage of these kind of built-in pieces of data and functionality that are part of the runtime error class. However, in C++, it is not required that any new exception class you create has to extend an existing exception class from the standard library. It is recommended that you do that, but in C++, technically, anything can be thrown in a throw statement. And so I could throw an integer, and then I could say catch int and catch it down here if I wanted to. You don't normally do that, but you can. And again, typically you'll do this with exception types rather than with random primitive types like int, as I just mentioned. So in the subsequent examples, we're going to take a look at some more of the mechanics of this exception handling mechanism and show you things like what happens when an unhandled exception occurs, and also what happens when a particular block of code doesn't handle an exception. Where does it go from that point? And you'll see a concept called stack unwinding as part of the next several examples as well.